So final exam up. Oh, good. Up until May the 9th. So the last day for the final exam is May the 9th. If you want to take it in the testing center, that's fine. I also have 3 classes that you can come and take the test with if you want, Dexter. Monday from 5 to 8 p.m. in this room. Tuesday from 5 to 8 p.m. in this room. And Wednesday from 2 to 4 p.m. in this room. If you don't like any of this, testing center has the test for you. Okay? Will anyone come to take the test with me? It's okay if you say no. Okay. Well, in that case, take it in the testing center because I have to take the test away from them. So if you're not sure, take it in the testing center because I will not have tests for you. I will have to go down and get the test and come up because they already have the tests. So let's leave it like that. But last day is May the 9th. Okay, so in the testing center. Good. I already posted solutions for test 4. We already went over those solutions. Okay, very good. So 3 minus 2i squared. How do I square a binomial? How many terms do I get?
3.
Good. So this is 9 minus 2 times 2 is 4 times 3 is 12. 12i plus 4i squared. What do I do next? Well, the answer is I replace I squared by negative 1. So 9 minus 4 will be 5 minus 12i. And that's a simplified form, and there is nothing else I can do here. Good. What about the second one? What is this? What could I be asked here to do? Well, this is a division of 2 complex numbers. So we're asked to divide. So how do I divide 2 complex numbers? Very good. By the conjugate of the denominator. Correct. So 4 plus 8i, 4 plus 8i. For the denominator is easy because I have a minus b times a plus b, which will be 16 minus 64i squared. And now we can weigh. But the numerator requires us to distribute, use FOIL. So 2 times 4 is 8, plus 2 times 8, 16i, 3i times 4, 12i, and 3i times 8i is 24i squared. At this point, I do what? Yes, I will replace negative I squared by negative 1, correct? And combine like terms. So this will become negative 24 plus 8 will be negative 16. And this is plus 28i. And this is negative with negative, right? 64 plus 16 will be 80. I separate negative 16 over 80 plus 28 over 80i. And I have to simplify as much as I can. Okay, so I'm going to try by 4. And I get 4 and I get 20. By 4 and I get 7 and I get 20. This continues to be simplifiable. So it's negative 1/5. I'll simplify by 4 plus 7 over 20i. Are we okay with complex numbers or we need something else? Okay, so yes, Reese?
Oh, I was just saying, I guess we'll go to something.
Okay, so let me list the topics of chapter 10 one more time. Radical equations, simplifying radicals, adding, subtracting, multiplying, dividing, squaring radicals, expressions with radicals, Distance formula, midpoint formula, Pythagorean theorem. I think I mentioned rational equations. And the graphs of the square root of x and the cube root of x. What would you like me to look at from this list? Okay, do I choose then? Okay.
I mean,
Okay, so let's look at a radical equation. The square root of 2x minus 1 plus 2 equals x. How do I solve this radical equation? What would be the first step? Aw. Of course. The square root of 2x minus 1 equals x minus 2. Very good. Excellent. Next step.
take this square.
Yes, very good. So I have 2x minus 1 equals x squared minus 4x plus 4. Now this becomes quadratic. I have to move these terms to the other side and set it equal to 0. So it's x squared minus 6x plus 5 equals 0. Of course, now we know 4 methods of solving quadratic equations. However, I'm not going to use the quadratic formula if it takes a few seconds to factor, because factoring is so much easier if it doesn't take a long time. So I see x minus 1 and x minus 5. And then the two solutions are 1 and 5. But they come with a big question mark. Why do they come with a big question mark? Because every time I raise both sides to a power, there is no guarantee. It's not a basic principle. There's no guarantee that the solutions will work. So it's part of the problem to do what? Yes, I'm going to copy the original problem right here. And I'm going to plug in 1 first, and then 5. So when I plug in 1, I look at this, and I look at my conclusion for a moment. The square root, I know the graph, it's always a positive number. A positive number plus 2, can it equal 1? A positive number plus 2, can it equal 1?
No.
No. Okay. So 2 times 1 is 2, 2 minus 1 is 1, the square root of 1 is 1, and 1 plus 2 does not equal 1. Therefore, I'll say this does not work. And now I will plug in 5. 2 times 5 is 10, 10 minus 1 is 9, the square root of 9 is 3, 3 plus 2 is 5, so I will say yes, acceptable. Questions, please. So this was a radical equation. Would you like me to continue choosing, or do you have something else in mind?
Yeah.
We are still working on chapter 10?
Yeah.
Yes? Okay, very good. Here's another problem. Let's say 98 on page 646. And 2 the square root of x minus 3 the square root of y multiplied by 2 the square root of x plus 3 the square root of y. Okay. I realize that this is the difference of squares. Would you agree?
Yes.
So instead of foiling, which you can do if you want, I will use the formula. The formula says a squared minus b squared. When I square this, I get 4x minus. When I square this, I get 9y. Yep. and there is nothing else I can do. For example, 93. 2 the square root of 50 minus 3 the square root of 125 plus the square root of 98. It is important to know how to simplify these radicals. So are they like radicals? Well, if I look at this, I will say no. But the versed student like you will say, wait a minute, give me a second to simplify each radical to the maximum, and then I'll tell you whether they are like radicals or not. Because right now in this form, I cannot really tell. They appear not to be, but I haven't simplified them, so I don't know what's behind it. So I know that 50 is 25 times 2. I know that 125 is 25 times 5. And I know that 98 is 49 times 2. And that's good enough. If you want, you can rewrite this or write this next step, the intermediate step. 2 multiplied by the square root of 25 minus the square root of 2 minus 3 the square root of 25 the square root of 5 plus the square root of 49 times the square root of 2. If this works or better for you, or it's visual or helps you in coming up with the correct next step, please use it. What do I do next?
Take out whatever.
Right. This will change into 5. This will change into 5. And this will change into 7. But this 5 has to multiply the 2 in front. 10 the square root of 2. This 5 has to multiply the 3 in front. Minus 15 the square root of 5. And this is plus 7 the square root of 2. And now when I look at this, I'll say, aha, yes, 2 of them are like radicals. The other one cannot be combined, though. So what will be the final simplified form? Yes. Minus 15 the square root of 5, and that's it. And we cannot further simplify. Good. We continue with chapter 5. Okay, let's rationalize. 110. The square root of 2 minus the square root of 3 over the square root of 2 plus the square root of 3. We want to rationalize. Let's say this time we are asked to rationalize the numerator. What do I rationalize it by? Yes, very similar to dividing complex numbers. Same idea. So the square root of 2 the conjugate. It's the same idea, right? We're asked to rationalize. Yeah, just for, changing it a little bit. We always have to, I shouldn't say always, 99% of the cases we rationalize the denominator. But in certain situations, we may be asked to rationalize the numerator for whatever purpose. Okay, the numerator is easy because it's a minus b times a plus b, which is 2 minus 3. Even the denominator is easy because they are the same quantity and I can use the binomial squared formula. If you say, well, I don't see it, let's FOIL, I'm fine. But this is still the same thing, same quantity. The square root of 2 plus the square root of 3 squared. The first term squared is 2 plus 2 times the first times the second plus the second term squared. Now we know chapter 7. This will be a terrible mistake. To simplify this 2 with this 2 or this 3 with this 3. What's wrong? Why am I not allowed to do that? Because our first note in chapter 7 was we simplify only exactly factors, not terms. Correct. Very good. So I can combine this. The top is -1 and the bottom would be 5 plus 2 the square root of 6. And there is no need to do anything else. Good. Do we need to look at a distance formula and a midpoint formula? No? Okay. Pythagorean theorem?
Yeah.
Okay, very good. So let's say we are given, this is problem 123. We are given this, 3, 3, and this is a right triangle. We're asked to find the side that is not known. Good. So what do I do?
3 squared plus
3 squared plus 3 squared equals? Indeed. So this is 9 plus 9, which is 18. So then, yes. Then I take the square root. But what I know from this chapter is, and also chapter 11, when I take the square root, I have to write plus or minus. So, and I know that 18 is 9 and 2. So this is plus or minus 3, the square root of 2. However, because we are talking about the distance, I will say only x equals 3, the square root of 2. And the measurement unit for this was centimeters. Centimeters, so this is centimeters. Okay, anything else from this chapter, or we move on to another chapter?
What's the chapter when we have to
Yes?
we have the numbers like a square root of maybe this is the same chapter.
Are you talking about completing the square?
Oh, maybe when we're doing like the exponents.
Yes.
I guess like rationalizing. I guess that's what like the examples 602.
Yes, page 602.
Yeah, like
Okay.
some of those.
Okay, let's take a look. Page 602.
And that is the same chapter.
Yes?
Yeah.
Any particular problem?
No, I just noted that in my notes that there's some problems on 602.
Okay, so let's do 56 from 602. Let's say 2x2 1/5 everything to the 4th power over x2 3 divided by 10. Is that something that you...
Yes.
Okay, perfect. So we're asked to simplify this fully. Well, I have 2 factors inside a parenthesis that is taken to the 4th power. I have to raise each factor to that power. So I have 2 to the 4th multiplied by x, and I multiply 1 over 5 by 4 over 1, and I get 4 over 5 divided by x to 3 over 10. Now the question is, what do I do with this? What will be the next step? How do I think about this? 2 to the 4th is 16, and there is nothing I can do to it. But then I will copy the base, and what do I do with the exponents? Yes. So from 4/5, I have to subtract 3/10. So 16 stays. What is the least common denominator of those 2 fractions? 10. So 10 is the least common denominator. What does the top of the first one need, and what does the top of the second one need?
2. The first one needs 2.
And 1. Very good. So 2 times 4 is 8. 8 minus 3. Perfect. So finally I have 16. X to 5 divided by 10. But 5 divided by 10 is the same with 1/2. And now I know what x to 1/2 is. What does x to 1/2 represent? Every time I have a fractional exponent, what does that mean?
Square.
Very good. Indeed, the square root of x. Every time I see an exponent that is a fraction, I have to have in mind, I have to think back at the radical. Good, very good. Anything else? Anything else from chapter 10, or we move on to something else? No, that's what I'm saying. I would like to review other chapters, but if you still have something from chapter 10, we'll stay on chapter 10. Remember, we had chapter 8, which had chapter 4, chapter 9, chapter 11. Yes, this was a chapter that you had to test today, so that's why I was thinking that it was still fresh in your mind, but yes, we can go back to chapter 12. I'm putting my attendance in. So what do we continue with?
Just like the touch on the function decomposition.
Yeah. So for the function decomposition, as an example, let's say I have f of x equals 1 over 2x minus 3. So we want an inner function. I'm going to call it f1, inner. And let's say f2, which is outer. So what will be the inner function? If you were asked to evaluate this, how will you start? Where will you start? What will be the first function you apply to x? If you're asked to evaluate this function for 2, which function would you apply first to 2? But can I start with 1 over x if I want to evaluate this function for 2? Do I start with 1 over 2? No. So what do I start with then?
I think I'm confused with what you're asking. You're asking.
So if I'm asked to evaluate this function for 2, I will have to do 2 times 2, then minus 3, I get a number, and then 1 over that number. It's the order of operations. So then the inner function could be 2x minus 3, and the outer function is 1 over x, right? So I perform this function first, and then when I'm done and I get one number, then I perform 1 over that number, which is another function. Does it make sense? That's function decomposition. Yeah, it's the order of operations. This is nothing new, right? So if I'm asked to evaluate for a particular number, I cannot start with 1 over, right, for this function. I have to multiply 2 by 2, then I have to subtract 3. When I'm done and I get a number, then I say 1 over that number. That's function decomposition. It's a composition of different functions. Yes. Next question. Is this better? Was the question clear now? Is it clear now? Okay. Good. Anything? Which chapter do we go back to then? Any ideas? I was hoping that you had time to look at all the tests and come back with a list of questions. That was the requirement, I thought. Because I would like to show you things. I don't want to waste the time.
So what about 8.3, the piecewise?
Yeah, exactly. It's a very good idea. Here it is. So let's look at the piecewise-defined function. Good. Thank you. I'm going to make one up. Okay, it is a piecewise-defined function. We are asked to graph it. What do I have to determine first? Yes. Domain is always the important point here. I'm going to change this into 3 because I want to have a gap. Okay, very good. So this will be replaced by negative infinity to 0, and this will be replaced by 0 to infinity. In case you like to use this method. So then I have x and then f of x, and the domain is between negative infinity and infinity as we see it. It's all real numbers. And 0 must be in the chart. Now, the signs or the symbols under 0 will be these. One opening to the right, and it's a bracket, and the other one opening to the left, the other way around. One opening to the left, it's a bracket, and the other one opening to the right, and it's a parenthesis, and they touch. So now, although I see it here, I will write it again. This is x squared plus 3. Although I see it here, I know this is the square root of x plus 4. And now I'll pick some numbers on the left-hand side of 0, some x values, and some x values on the right-hand side of 0. Okay, well, I'm going to say -1. Let's say also -2 and -1. When I plug in -2, I get 4 plus 3, which is 7. When I plug in -1, I get 1 plus 3, which is 4. And when I plug in 0, I get 3. Do you agree with these 3 ordered pairs? What type of function is x squared plus 3? Quadratic, chapter 11. Does it open upward or downward?
Upward.
Yes, because the leading coefficient is positive. So it has a minimum. Perfect. On the other side, I plug in 0. The square root of 4 is 2. Give me another number to plug in. So that is easy to take the square root from. It's a perfect square. 9 plus 4, but you mean 5. Correct. I agree. So 5 plus 4 is 9. The square root of 9 is 3. Good. What type of function is this? Very good. So it's not a line. Okay, it's not the absolute value and so on and so forth. We know a lot of functions. We learned a lot of functions in this class. Remember, linear functions, quadratic, linear, quadratic, absolute value, right? Yes, x squared, radical, square root, the cube root,
Which is like,
the exponential, the log, a lot of functions. Okay, so let's graph this. I see negative 2, 7. Right here. Negative 1, 4. 1, 2, 3, 4. It's a full point because of the bracket, and it opens upward, and it's a parabola, and it has to stop at the point 0, 3. Now I will graph the other side. 0, sorry, 0, I didn't graph I didn't put the last point. I'm sorry. Thank you. I just realized. So 0, 3 is that point, and it's a full point. Now I'm going to graph 0, 2, plot 0, 2, which must be an open point because there is a parenthesis here. And then 5, 3. 1, 2, 3, 4, 5, and 3. I know how to graph this. It's not a line. It's a square root function. Can anyone identify the range of this function? Exactly, with a parenthesis, because this is not a full point. Very good. Excellent. Good pick. Good idea. Good, next topic. Next topic. Anything from chapter?
like union.
Yes, that's in chapter 9. In which we had compound inequalities, absolute value inequalities, and absolute value equations, and graphing systems, linear systems of inequalities, in which we had to shade in. So would you like an absolute value inequality?
Yeah.
Yes?
Yes.
Very good. So let's say 3x minus 1 divided by 4 in absolute value greater than 2. Okay, how do I solve this inequality? What do I have to do? What do I have to write first?
Domain.
No, I have to remember what type it is.
So like that or even to the value like the same but negative.
Say it again.
You have that.
3x minus 1 over 4 and 3x minus 1 over 4.
Yeah, the one's like equal to 2.
We cannot change an inequality into an equation. I can't give any credit if you do that.
So like one negative 2 and one is 2.
Right, but how do I write it?
Oh, you put the -2 on the other side.
So 3x minus 1 over 4, and then?
So then
Greater than
Greater than 2, correct, perfect. And the other one?
Oh, you flip this side. You flip this. to
Okay.
negative.
Correct. Because this inequality says, find numbers whose distance from 0 is more than 2. More than 2 means outside. To the left-hand side of -2 or to the right-hand side of 2. Good,
But
good.
don't you write it as 1? Can you not write it as?
I cannot. That's not, it's not for greater than. These, it's for this.
Oh, for the
It's
outside.
not for this.
Okay.
For this one, I will write it as 1. It will be much easier. But this one is the outside. Very good. So I will multiply both sides by 4. So I have 3x minus 1 greater than 8. I will add 1 to both sides, and I will divide by 3. I will repeat. Multiply both sides by 4. 3x minus 1 less than negative 8. I will add 1. 3x less than negative 7. So x less than negative 7/3. Now, how do I write the solution? The final answer. Yes. How?
So, infinity.
This was just trivial, right? What we've been doing for a long.
So negative infinity
Yes,
to negative 7.
of course. And union 3 to infinity. X in the interval. Yes. Very good. Good job. Good. Your homework is due today. You have it? Because I'm going to post solutions tonight for you to look at. If you do, it's okay. If you don't, I still have to post solutions. Good. Anything else? Other chapters, other topics, anything you'd like to go back to? These were very good. Please review everything. Please. Please. More than once. Please. More than once. I would say 3 times. All tests, all solutions. What solutions?
Still helps go
Yes. I
on
agree.
top of, like, other classes.
I agree. I agree. I know. Every professor thinks that this is your only obligation in life. I know. And I know it's not. But especially in math, I'm less familiar with other topics, and I mean with other disciplines, but especially in math, it requires constant effort. I wish I could say otherwise. Okay. Next step, next problem.
What about when you have the two equations, inequality functions, or you have to graph them and shape
Yes, systems.
system?
Yes, that's at the end of chapter 8. I'm lying. It's at the end of chapter 9. Sorry about that. End of chapter 9. Let's say 2y minus x greater than or equal to 1 and x plus y greater than or equal to negative 4. Good. So the first step is I'm not changing the inequality into an equation. I have to write the equation because I need to graph it. And that will be 2y minus x equals 1. It's a linear equation. When x is 0, y is 1/2. So 0, 1/2. When y is 0, x is negative 1. So negative 1, 0. I will graph the equation. 0, 1/2, negative 1/2, negative 1, 0. I stop for a moment and make sure that the inequality symbol is there. Yes, it is. And then I will graph a solid line. And this will be 2y minus x equals 1. This is not the inequality, this is just the equation. Now, I'm checking this territory because I decided to pick 0, 0. Since I want to pick 0, 0, 0, 0, 0 greater than or equal to 1, no. So I cannot shade in the origin, the area that has the origin. I have to shade in the opposite. And this will be 2y minus x greater than or equal to 1. I repeat for the second one. The same steps for x plus y equals negative 4. When x is 0, y is negative 4, 0, negative 4. When y is 0, x is negative 4, so negative 4, 0. 1, 2, 3, 4. Negative 4, 0. And 0, negative 4. 1, 2, 3, 4. Does it have the equal symbol? Yes. So I will graph a solid line. On the line, I will write x plus y equals negative 4. I will check the upper area, checking or using again the origin. So with the origin, 0 greater equal to negative 4. Yes, indeed, that is true. So I have to shade in the area that contains the origin, the point that I used to verify with. Okay. At this point, I'm trying to find a common territory where I see blue and red at the same time. Well, I see blue and red at the same time all over here, this line, and everything in between. So this is both at the same time. So the solution to the system of linear inequalities in two variables is anywhere, any point in this territory. To the right of the red line, to the left of the blue line, and anything in between, in other words. There is no other way of writing or presenting the solution. Questions? Is this what you meant? Is this okay? Okay, perfect. Next question.